Good day everyone, this is a chapter 5 Geometric Design Lesson 1 The Transformation, Patterns and Diagrams. The reporter Beretta Arlette, Innocentes Judy, Innocentes May and Jacob Amira.
Transformation. Definition and overview. What is a transformation in math? The transformation definition in math is that a transformation is a manipulate of a geometric shape or formula that maps the shape or formula from its image or original position. It is image or after transformation position. Figure 1. An example of a transformation. This is a reflection of shape A over the y-axis. An example of a transformation. Thus, a rational in math change the size or shape of the image that is rotated. Translation. Image placing a coffee cup on a counter. Pushing the cup from the edge of the counter to the middle of the counter is the same of translation. The cup from the edge of the counter to the middle of the counter. Share. Image drawing a square. Now image grabbing the top to the square and walking it is to the right. The result is a parallelogram or a square. See the figure 7. Transformation math rules. There are many ways to transform a geometric shape or a function in math. But regardless of the type of transformation that a shape or function undergoes, once transformation math rules always applies. A rigid transformation in math never change the angle involved. Go back and look at each figure in this lesson. No matter how a rigid transformation change the image, the angle, and the resulting image are always the same.
Recognizing and analyzing geometric shapes involves identifying, understanding, and evaluating the properties, characteristics, and relationships of different geometric figures. It is a fundamental concept in mathematics and geometry, helping develop spatial, reasoning, and problem-solving skills. The key components: number 1, recognition, identifying shapes like circle, triangle, rectangle based on their defining figures, differentiating between 2D and 3D shapes. Number 2, analysis, understanding properties, number of sides, angles, analyzing relationships between shapes such as congruence, similarity, or transformations. Number 3, classification, grouping shapes by attributes like the number of sides, angles, or dimensions. Number 4, measurement, calculating perimeter, area, surface area, or volume, comparing size, proportions, and other metrics. Number 5, application, using geometric shapes to solve real-world problems like designing objects or understanding patterns.
Transformation. Definition. Transformation are actions that change the position, size, or shape of geometric figures. They involve moving or manipulating figures in a specific way. Types of transformation. Translation, sliding a figure without changing its orientation. Example, image moving a chess piece across a board without rotating it. Mathematical representation. A translation can be represented by a vector that indicates the direction and distance of the shape. Reflection. Flipping a figure across a line, the line of reflection. Example, image holding a piece of paper up to a mirror. The reflection is a mirror image of the original. Mathematical representation, a reflection can be represented by a line of reflection and the rule that each point is reflected to a point equidistant on the other side of the line. Rotation, spinning a figure around a fixed point, the center of rotation. Example, image turning a wheel on a car. Mathematical representation, a rotation is represented by the center of rotation, the angle of rotation, and the direction, clockwise or counterclockwise. Dilatation, changing the size of figure, making it biggest or smaller. Example, image zooming in or out on a picture on your phone. Mathematical representation, a dilatation is represented by a scale factor, a number that indicates how much larger or smaller the figure becomes.
Number 2. Patterns. Patterns are predictable arrangements or sequences of objects, shapes, numbers, or other elements. Types of patterns. Geometric patterns, repeating shapes or designs. Example, tessellations or tillings are geometric patterns where shapes fit together without gaps or overlap. An example is this. We can see the crosses have no gaps and they fit together exactly. The same with this example. Another example is patterns in wallpapers. We can see in this example picture here, 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 and here. We also have patterns in fabrics. Like this. And also, we have examples in architectures. Like this dome-shaped structure. Numerical patterns. Sequences of numbers following a specific rule. Example, the Fibonacci sequence, where each number is the sum of the two preceding numbers. An example of this number pattern is the arithmetic sequence, adding a constant value to each term, or geometric sequences, multiplying by a constant value to each term. In this example, our pattern goes 8, 16, 24, 32, 40, and 48. And we get this pattern by adding 8, positive 8, from the preceding number. Color patterns, repeating colors or color combinations. Example, a rainbow pattern alternating red and blue stripes, or a repeating sequence of different colors. Like these pictures. We have this warp-like illustration, this spiral illustration. Number 3. Diagrams. Diagrams are visual representations used to illustrate concepts, relationships, or processes. Types of diagrams. Geometric diagrams representing shapes and their properties. Example, a triangle with labeled angles and sides. Here, an example is this here. With angles and sides. Another example is a circle with its radius and diameters labeled. Like this one. Next is flowcharts, showing the steps of a process or algorithm. In this, we can see steps of a process. When a lamp does not work, we check if the lamp is plugged. If it is not plugged, we plug it. But if it's still not working even though it's plugged in, we check if the bulb is burnt out. We then replace the bulb or repair the lamp. There's also an example of a flowchart for a computer program, a flowchart showing the steps for solving a math problem. Then we come to graphs, visualizing data relationships. An example is a bar graph showing the number of students in different classes. But in this graph I'm showing you is the favorite color of students in a class. From preschool, primary, to secondary. And our last example is a line graph, showing the change in temperature over time. In this case, I'm showing you a line graph about the number of books Sarah read per month. Number of books read 0 to 7 and the 12 months of the year from 2020 to 2021. That's it. Thank you.